Hey, good morning, everybody. This is Nigel Mbayek from KETIV Technologies. Happy holidays to you all. Definitely looking forward to a little vacation at the end of this week, definitely. So I'm hoping you guys are all looking forward to that too. Today, we've got actually a different kind of AVA today. As you can see on the screen, it's an Ask the Expert. This is something we've been wanting to try since, AVA kind of started, and we found a good opportunity to do so. We got into contact with Dave Graves from Autodesk, and that's who we have here on the line. Dave, how's it going?
I'm doing great. Thanks for having me today.
Yeah, definitely, and thank you for being here. So Dave will give you a little bit of background about himself on the next slide here, but I do want to let everybody know if you do have any questions at all during this webcast, we want to kind of keep it as interactive as possible. Go ahead and type those questions into the chat bar at any time. Anything about simulation, any of the concepts, what the products are capable of. Things like that, definitely feel free to type those in. I asked everybody for questions on the reminder email yesterday, and I have my list here. So we'll be going over a couple of those today. Jump into product a little bit and talk about kind of the concepts of validating and innovating your designs using some of the tools available to you via your Autodesk software. So with that, I think we'll jump to the next slide here. And Dave, you want to start introducing yourself a little bit?
Yeah, absolutely. My name is Dave Graves. I'm actually based here in Charlottesville. I'm debating whether or not I should throw my webcam up, but I'm a mechanical engineer. I went to NC State University. Don't know if we have any Wolfpack fans on the call, but enjoyed my time there. Right after school, I spent the majority of my career working in telecom. So I've done design work, I've done manufacturing, different project management, people management, testing, kind of the whole gamut as far as telecom goes. Big telecom bust, and then I forget when it was. I think the early 2000s, and had the opportunity to go and start working for a company called Blue Ridge Numerics. Pretty exciting. I think I've always been passionate about how do you leverage kind of 3D data. I was really, even though I'm an Autodesk employee, I was really excited when I started to use Pro Engineer and be able to generate 3D content. So the fact that me, just an average engineer, could start doing simulation, it was an exciting opportunity, and that was well over 10 years ago. I was been exposed to all types of simulations, from internal flow, valves, external flow, of course, telecommunications, electronics, cooling, cavitation. You can see a bunch of valves, pumps. So I've done almost everything you can with our CFD tool. And for those of you who aren't familiar, that tool was originally called CF Design, and it was acquired by Autodesk about 6 years ago, and it's Autodesk CFD now. I just joined the CFD team, came back about 6 months ago. Prior to that at Autodesk, I was working on the Fusion team, on the manufacturing team. So I've gotten involved with our tools like Sim Mechanical, which I know is going away, our Fusion Ultimate Simulation, and even our Nastran in CAD. So I have a pretty good knowledge of all those tools. And Niles and I were talking, this is kind of exciting, kind of nervous. So we have a little bit of stuff prepared, but for the most part, we just want to be here to answer any questions you might have. So feel free, as Nigel said, to chat them in, and we're going to do our best. So that's enough about me, Nigel. Why don't we just keep going?
Awesome, cool. So what I'm going to do here real quick is I'm just going to throw a poll up onto the screen right now, just to kind of get a little bit of a background on what everybody is using, whether or not you're using simulation or not. So feel free to answer that poll question. We'll give everybody about 15 seconds or so to do that. Just want to get a little bit of a background of the audience as it sits right now, kind of get an idea of what tools maybe you're using. Maybe you're not using any tools. It can help us, point the conversation in one way or another. So cool. It looks like we've got a pretty even spread here. We've got about, a quarter of the people using InCAD, a quarter of the people using some other simulation tool, about 15 to 20% CFD, and the rest might not even be using tools right now. So that gives us a pretty good idea of what people are actually using. So that'll help steer some conversation there, Dave.
It's awesome.
Cool. Awesome. So let's continue here on this little slide deck we've got here. So a couple of these things here on the screen. Just take a minute to read those. These are all things that help us as manufacturing companies, or help you as manufacturing companies. These are kind of things you have to design too. things that you have to keep in mind when you're designing your products, right? You want to be able to, for example, warranty and reliability there in green. That's something you want to build your products to. You want to build your products more reliable. You want to make sure that they don't break when they're in the field, because those things get super costly as you make changes later on. And that's something we'll show a little bit later. So these are just a couple of those terms that you want to keep in mind, that we all keep in mind when creating products for the market. Dave?
Yeah, I'm sure Nigel, I'm sure everyone on the call can probably think of a couple other things. I just like to take a step back and say, all the customers I talk to, I don't think there's any customers out there that say, yeah, I want to make more expensive products that perform worse and take longer to get to market, right? Those goals of getting things to market quicker and improving your quality, reducing cost, have been around for years, and they're going to continue to be around for years. So all these things tie into that, and hopefully simulation can help meet some of those goals.
Definitely. And so just simple here, the power of simulation is to make better decisions sooner in the design process, right? We'll mention and we'll show a little graphic about it later. I can't think of any scenario where making a change to your design late in the process is going to save you money, or it's going to cost more the later you make a change. And I'm sure we can elaborate a little bit on that moving forward. So like I mentioned, if you have any questions, definitely chat them in, and we'll go ahead and address those. But like I mentioned, we did get a lot of responses on those emails yesterday about questions we wanted to cover, and we'll go ahead and cover a couple of them directly here. So the first one, what do you think are the most common mistakes users make when using simulation tools? This is a great question. I figured we'd embed this straight into the PowerPoint. I think this is going to be really hit home for some people. I know that when I went to school for mechanical engineering, similar to Dave here, it was a little daunting when I first got in. It's like, okay, we're going to do simulation tools, and you guys are going to, validate your designs and create more innovative designs by running simulations on them as opposed to building physical prototypes. It's difficult, right? You don't want to be responsible for something exploding. You don't want to maybe necessarily learn how to do something else. Those are a lot of the big hurdles that I see, especially talking to some customers about simulation. But really, it's not that difficult. Dave, do you have anything to add to that?
Yeah, it is a great question, and I think there's so many parts to this. I think the first thing when people think of simulation and the way people traditionally use it is they want to use it as a validation tool. And we talk about finite element analysis, I think people are comfortable with that because I can physically take a bar and bend it and see when it breaks, and then I can simulate that. So most people think about validation. To me, where we forget or what we don't do enough of is use the tool to innovate. So I think there's so much more value in using it for innovation versus validation. What typically happens is you get the tool and you want to match your test data, and you spend all the time, all the simulation tools, not just ours, they have all these little hidden buttons and dials, and we can match or correlate to any test data. The challenge, as I say, is during that time frame, you could have explored 5, 10, 20 different ideas, and not necessarily passed your test, but come up with a product that's superior. So I don't know, maybe not, like just ask a couple questions that people can put their hands up and just frame it in a different context. The question is how many of you, when your boss comes to you and there's a problem and you only have one idea on how to solve it? So Nigel, there are a lot of hands up.
Let me see. If you guys want, there is a hand up question, or there is a hand up button to raise your hand. I know that just based on the customers that I've talked to personally, that is something that resonates with a lot of them. So
yeah, I mean, I talk to people, and when a group of people, you'll say, well, how many people have at least 5 ideas on how to solve a problem? Hopefully a lot of hands are going up. You guys are probably twice as creative as I am. And then you flip it and say, well, how many ideas do you actually prototype or test? 90% of the people say 1, sometimes you get 2. Mm-hmm. And then why is that? Well, it's because, to your point, Nanja, you don't want things to blow up. It's risk. You want to go with the most conservative one, the one you know the best. So all you're really doing is taking your testing and validation, instead of physically testing, you're virtually testing. And don't get me wrong, there's a ton of value in that. I just think the most common mistake is you're so worried about getting exact numbers, you're not looking at what's influencing those and how you can make your design better. So something I'm passionate about, this whole concept of upfront simulation. So I think that's the biggest mistake people make with simulation tools, is they focus on validation. So that was a long answer. Sorry about that, Najee. It kind of got me going.
No worries, no worries. And I think that's what we're here for, right? Is we're here just to have a nice open conversation, you know, answer anyone's questions about any of the concepts, and kind of answer a lot of these sent in questions from those emails yesterday. I think that also kind of ties into this next question here. What do you see are the most common barriers to people who haven't started using simulation? And I talked a little bit about it when I was answering that last question. I think one, there's that like inherent perception that simulation is like really difficult and I need to be an analyst to do it. Dave, I'm sure you hear that a lot.
Yep. And you know, I like to Naj and I were joking. I am not a PhD. I do not have a master's degree. I don't even have a PE license. I mean, parts of me wish I do, but I understand, at least, you know, when I initially started, how products work and the basics of my design and what I want to accomplish. So most people still think, oh, FEA tools, oh, simulation tools, I need to have that advanced degree knowledge. I need to know advanced materials. I need to be able to integrate equations. And that is so far from the truth, because I think, again, people are focused on the validation, not the innovation. Definitely. So if you're nervous or you're scared, I mean, all I can say is give it a try. Talk to Nigel. The guys at KETIV have some great resources. They absolutely know how to get a hold of me. And, you know, we can start simple and work your way up. That's the easiest thing to do, is just believe in yourself, and you guys can be super successful. I have no doubt.
Certainly. And there's so many resources, not even just us, right? There's all of the tutorials built into the help documents for all of the products. There's also, you know, we can reach out to people at Autodesk to be able to help us. There's tons of content on YouTube. Whether it's from us, whether it's from other resellers, stuff like that. It's all out there. There's like, in this world, we don't have to like read novels anymore to be able to figure stuff out. There's a lot of interactive tutorials, and just makes that learning process so much easier with the tools. Also, I hear a lot of, you know, I don't have time for simulation. I'd rather just immediately start getting to that physical prototyping stage. And then another one I hear about is it doesn't do everything I need it to. And Dave, do you have anything to add about that?
Yeah, you know, so you know, lots of examples where, well, it doesn't do combustion, or it doesn't do this phase change, or it doesn't do this particular physics. And the reality is most of the tools can get you 80% of the way there, at least to understand what happens before that advanced physics. You know, generally with flow problems, it's about flow uniformity. It's about pressure drop. It's about optimizing those. Maybe it's about reducing cavitation. So, you know, again, it goes back to the validation versus innovation. To validate, yeah, you need to have more of those physics and more of those capabilities. That's going to cost you runtime and complexity and confidence. Whereas, you know, if you're going to explore your design, you don't need, it doesn't need to, you know, you don't need to dial it in within that 2% accuracy. It's just a lot of time for, you know, you can get 80% of the way there with most of the tools that we offer.
Definitely. And those are just things to keep in mind when, you know, maybe I want to start, but where do I start from? I
think that's the biggest barrier, is where do I even start? And that's something we can absolutely help you with.
Definitely, yeah. Just reach out to us. Feel free to do so. So this slide gives us, you know, just some of those questions that we asked. I'm sure everyone who builds a product on this call probably has to ask themselves one of these questions. How light can I make my products? How do my, you know, how does the assembly interact with one another? What happens? Will my part fail with this certain load on it? Things like that. And these are just some of the answers, some of the questions that, you know, simulation can help you get some of those answers. So definitely, if any of these questions do resonate with you, and I'm assuming at least one of them does, there is probably some opportunity for you to leverage some of the simulation tools to be able to, you know, make your lives a little bit easier, not have to ask these questions. I'm 90% confident my part will not fail. You know, you can be a little more confident than that by using some of the tools. So, and here's a really, really interesting slide I like to show a lot when we're talking about simulation. And Dave, do you want to explain this this a little bit with regards to cost and
yeah. Hopefully I'm not going to date myself too much, but this is a great example that hopefully everyone remembers with the Xbox and the red ring of death, right? Microsoft many years ago released an Xbox, got it on the field, but it had an overheating problem. And so they did a great job, but think about what that cost them. That arrow that Nigel had was all the way over to the right. You know, think about the automotive industry. When they have to do a recall in the field, you have to take your car in and there's liability. It costs you exponentially more than if you'd found it digitally, if you found it before you even built the first one. And I think that's the idea here. The sooner you can improve the design, the sooner you can find issues with the design, the sooner you can innovate the design, then you're going to have a cheaper product. But the longer you wait, so some people use simulation to do post-analysis, right? Something failed in the field, let me do simulation to find out where it is, and that's fine, there's a place for that. But think about what that's gonna cost you now. You have to come up with a solution, you have to come up with work instructions to send it out there, then you have to get somebody to actually fix it. So again, the decisions you make earlier in the process pay huge dividends downstream if you don't have to retrofit or fix or update.
Definitely, and I think that definitely, I know that I had a couple of conversations with a customer a couple of weeks ago where they had this large assembly that was breaking, and they had to send a technician out there to weld a bracket onto this assembly to make sure that the parts wouldn't come apart, and they wouldn't have failure. And that that's a lot more costly than engineering that bracket into that original design.
Yep.
So
happens
cool.
all the time.
Yep. So another question that I got yesterday, the simulation product matrix I looked at shows thermal studies in both Nastran and CAD as well as CFD. Which one do I use? I think that question's a little bit, we need a little bit more background on a question like that, but definitely, Dave, if you want to answer.
Yeah, it comes up all the time because it's also thermal capabilities in Fusion, right? So besides in CAD and Fusion. And basically, the most of the thermal analysis in FEA, it's primarily focused on conduction. So if you think about that bracket that Nigel, you see in that leftmost image, if you were to think about that bracket on a stove and there was a heat source underneath it, if you put your hand on top, how hot would it get, right? That's the strength of FEA, doing those quick conduction analysis. There's the ability to do radiation. There's also the ability to use what's called a convection coefficient or heat transfer coefficient. So what that does is says, okay, let's assume we're losing some heat to the atmosphere. And Nigel asked me, he's like, Dave, where do you get this information to come up with this coefficient? And that's kind of the challenge. For if you're going to do things that are truly very little airflow around it, you can probably use a film coefficient of around 5 watts per meter squared and get ballpark. But as you start increasing the flow around something, so think about that bracket on the left. If you were to have a fan blowing air over it, it would get a lot cooler, right? But to come up with that film coefficient is pretty much, in this day and age with that geometry, black art. And that's where, if there's going to be air, water, any fluid kind of dispersing the heat, that's where you want to jump into CFD. So just another example, if I am designing a part and I have a heat sink on it, maybe I can do a quick study in CAD or Fusion to come up with ballpark temperatures of the parts. But if I want to design the heat sink or optimize the heat sink, I'm going to have to take it to the next step in CFD and look at the actual flow going around it, because that film coefficient is going to be somewhat variable based upon what's going on in the surroundings. So I don't know if that answered the question, something we can show, but that's kind of the break point is, once there's air or fluid, I should say, not just air, that's contributing to either adding or removing heat, then you really need to look at a CFD code.
Cool, and that helps answer a lot of those questions. I know I have a lot of customers that I've talked to who do electronics cooling, and when you are talking about those fans, definitely it is a CFD problem at that point. That's probably better optimized to help you figure out what's actually going on in that actual assembly. So, like I mentioned, here's a slide with the entire Autodesk simulation portfolio. If you have any questions about any of this, definitely let us know. We can help answer what you have, what you don't have, how you get blank, so forth. So let's keep moving along here. More questions. What simulations can I perform in the cloud? How does this work? Is my data secure? This is a question I got from 4 people actually, which is really interesting. Some of them in the context of Nastran and CAD. They're all the questions are slightly different, but this is the gist of all of those questions.
I was waiting for Nigel to say, is it faster in the cloud? Because that's another question I get too.
That is another one too, right? Is it faster?
So yep. So today, with Fusion and with our CFD product, we offer cloud solving, and the real benefit is somewhat speed. You know, they're virtual machines. They probably can be better than older hardware that you may have, but the real speed and the real benefit of the cloud comes into the fact, again, doing where you want to compare multiple designs, you want to run multiple studies. Maybe it's in Fusion, you want to run different load cases. Maybe in CFD, you want to run 3 or 4 different types of geometry. When it's in the cloud, excuse me, it's going to run in parallel. So let's just say, argument's sake, it's the same speed whether you run it on the one simulation on your machine or on the cloud. It's probably faster in cloud, but say they're roughly the same. If you're going to run 10, it's going to be 10x faster in the cloud because they're all running at the same time. Versus locally, it's going to be one at a time. Not to get too excited, you may have seen some stuff. We're working on a solver. We call it CFD or Cloud Premium. Still initially released, but we have some work on it. And what we're going to start seeing is some incredible speed up times, orders of magnitude once we get it all worked out. So that's where the cloud's going to come in. And Multiflow actually works in the cloud as well. I forgot that too. So Multiflow you can solve in the cloud. Thanks for that slide, Nigel. And again, the benefits are you can do more simulations in drastically less time. As far as security goes, we have a whole trust center. We have a whole paper we can send you. With simulation, the data is really just sending bits and pieces up there, and it really can't be put back together until it comes back to your local machine. It's the same kind of ISO, I think I want to say 26001 or one of those big numbers where it's as secure, if not secure, than most of the financial institutions. All the data goes to, you know, all the server farms. They have 24/7 security access and a bunch of those other parameters. So it is incredibly secure, and we have a whole trust paper and whole group that can answer any cloud security questions you might have. I use it a ton. I mean, I'm probably going to have to pay back some of the cloud credits I use because I use it a ton for CFD applications.
Definitely, and I use it a lot too when I want to use my computer when I'm doing sims.
And before you ask, I have no idea when Astra and InCAD is going to be in the cloud. If I did, I would gladly tell you. But you know, I step back and say, well, Fusion is Nastran based, InCAD is Nastran based. You would think at some point they'd be able to offer that. So hopefully it's in the works, but I don't know anything about that.
Cool. Yeah. Question check. So we got a couple of questions that came through the chat actually.
And you're going to keep me busy today, Nigel.
Yeah, this is a lot of stuff. So we've got a couple of questions here. Let's see, this first one, just in general, how is convergence assessed in, I guess we can use CFD or InCAD as an example.
Yeah, maybe maybe you can show my screen real quick.
Yeah,
Nigel.
let me swap to you real quick. One moment. And make presenter. Perfect.
All right,
While we're waiting for Dave to present there, and in addition to that, how is the error of the analysis addressed? I think those kind of fall hand in hand.
Yep. So first of all, let's if we talk about something like InCAD, I believe they do a mesh sensitivity study. So convergence could be as you increase the mesh, it'll refine it, and you'll see less of a differential. CFD, of course, I like to say, you know, we're a little more complex because we're solving a lot more equations, but you know, let me run something real quick. Hold on. You can see this live, and I'll explain what's going on here. So CFD, run it locally here. See, just if you ever want to know if you're running CFD, you have the choice to solve locally in your computer, the cloud, this cloud premium I'm talking about. You actually have the ability to you know, solve anywhere in your network that has CFD installed on it. So it's kind of cool. But as we solve this, I'm going to talk in a minute because the CFD code has introduced something called convergence assessment. But the manual way to assess it is going to be like this. You're going to see this is our status window or output bar. As you run this, once it starts running, it's going to switch over to the plots. Our CFD plots by default are not residuals. Residuals are what the analysts use. What our convergence plot tracks are the average variables for each of these quantities, whether it's velocities, pressure, temperature. These are right here. These are turbulence models, and then scalars for mixing. So you're looking at the average value. And it's going to start out and you're going to see them kind of go all over the place. But the idea for a converged solution is going to be the fact when these lines kind of get horizontal. I'm going to let this run. It doesn't take too long, but you're going to see, you're going to say, get the end and say, oh, this doesn't look horizontal. But what manually, if you want to assess it, what you can do is look at a certain range. So it's on iteration 11 right now. If I wanted to, I could look from iteration, we'll say 15. You can see I can change it on the bottom to 25, and it's going to give me a smaller snapshot of it. So before we had what we call convergence assessment, we used to actually instruct users to actually look at the last 5 or 10% of the iterations. What we've done since then, I'm going to hop over to another model real quick, but what since we've done this was many years ago. But when you solve, there's a button here for solution control, and then there's something called intelligent solution control. And what that does is it actually, as it's running the analysis, it's monitoring different variables to assess convergence. So the convergence slope is that horizontal value for all the parameters. And then the same thing, field fluctuation, very similar, but you can do tight convergence, loose convergence. So again, if you're innovating and exploring designs, maybe you don't need tight convergence. When you get to a validation of farther in the state, you can actually turn that on. And what the software will do is when it assesses that, those convergence plots will automatically stop. So that's kind of how CFD, how you manually assess convergence. But again, that's also built into the automated behind the scenes if you want it to be. Another thing for, and the FEA codes have this too, is this idea of mesh adaptation. So what mesh and again, the way I look at simulation is a big funnel. So let's start out looking at early concepts with 5 or 10 different concepts. Those are going to kind of whittle down into 2 or 3 good ones, and then you're going to get to a final one, and maybe that's the one you want to dial into within 5 or 10%. And a way to do that is to turn on something called mesh adaptation. Fusion has a very similar, apologize, I know I'm jumping all over the place into all these different tabs, but Fusion, if you go up into the adaptive mesh, it'll do the same thing. I can say, well, let me run an iteration. And basically it looks at the solution and says, okay, there's a high, in FEA, there's a high concentration of stress here. In CFD, well, there's some field fluctuations from velocity here. Let me add more mesh in that iteration, run it again, and do that a certain number of times. And that just, the mesh is the mathematical formulation of the model. You guys probably have seen all the little triangles and stuff here. We'll show it in CFD. Where's it right here? If I just go into my model here, right? In case you don't know, I don't know if some people are familiar, some aren't, but basically all the simulation codes, what they do is they take your 3D CAD model and they break it down into little pyramids, and then we do the math between those pyramids. So the mesh adaptation will refine that mesh accordingly, however number of iterations you tell it to. And with all the software, both FEA and CFD, it'll tell you it changed, it's 90% converge, it's 99%. It'll tell you the status of that adaptive mesh. So hopefully that answers that question a little bit. It's a lot of information there, but hopefully it got you on the right track.
Definitely.
For CFD, let me just, CFD, I only ran 100 iterations here. Let me go back here, hold on.
And then
you probably want to run more, but go ahead.
Yeah, and a question kind of that is an extension of that is like, does the same thing exist, the convergent plot in CAD as well?
I think it does. Let me find out for you, Nigel, if you want to get that information. The interface has changed recently, but I know those in CAD guys. I am 80% sure it's in there. I would show you, but I'm not sure where the button is.
Yeah, I'm almost positive that it's in there. And I can find that for you, Connor, if that's something you need to see as well. Let's see. And while you're going through there, just gonna take a look at some of the other questions here. Our biggest struggle with Nastran, and I guess this could go with CFD or Fusion simulation in general, is debugging when a simulation fails. In CAD specifically, yes, the most common thing they see is singularities. Is there an easy way to kind of identify what the culprit of that is, whether it's a specific node and things like that?
I wish. No, I totally agree. I think our error reporting is horrendous. I think because in CAD, came from the world of Nastran, so it's all this Nastran speak that I'm not versed in. One thing I've talked to some of our in-CAD guys, and what they recommend is when you get some of those errors, is actually to run the model, run a modal frequency of the model. Make sure that runs first. That'll generally highlight some of the errors better. We are working on getting better error reporting. Hopefully Fusion's going to be a little bit better than in CAD, but I'm on your side of this. I totally agree. It's if for CFD we'd have this miraculous code, CFD mesh encode error 60, and you're like, what is that? We're working to make the help better. We're working to give not English answers to some of those. But again, I've heard start with that modal analysis, and that can help. Once that's okay and that runs, then you can progress to a linear static, and some of those issues should go away. The other one I always get is, stiffness matrix and unreasonable material. So some of those I scratch my head as well. Just keep posting on the forums and posting support. And I wish I had a better answer for you.
Definitely, yeah, and I agree, especially with the modal thing. Just run a modal analysis. That's something Jorge told me a long time ago when I kept literally blowing up my NCAD. And then I found out it's like, oh, like I didn't, apply this load properly, or I didn't apply this constraint properly. And that kind of helped me figure out, it's like that modal analysis is definitely not what I expect this model to do. So it's a couple things in regards to that. Let's see. And yeah, so there's questions like, is this being recorded for review? Definitely. All of these are recorded for review if you want to. They're going to be on our YouTube channel after the fact. You can also reach out to us. We're live human beings. We accept questions for the most part. So yeah, we can do that as well. Dave, I think we're good on so far on some of those questions. Some of them that are in here, I might take a little bit longer to answer. Specifically yours, Mr. Brian Kelly. I'll get back to you specifically on that one. So I think we can move on. Let me go ahead and take the reins back on this, and let me go ahead and show my screen. All right, are we all looking at? Yes. Okay, cool. We're all looking at the right screen. More questions I got from yesterday. I get a lot of non-inventor files from my vendors. Can I use those in generic simulation CFD? If so, do I have to do things like file conversion to generic file types like STEP or IGES files? And this comes up a lot. Just because someone's not sending you a native inventor file doesn't mean you can't use Nastran. There are totally ways to do that using some of the power of things like AnyCAD. Same thing with CFD. You can open just about anything in CFD, if I remember correctly. Dave, correct me if I'm wrong.
Pretty much, yeah. If you can open it in Inventor, or you can open it in CFD, I think that's the thing. If you step back and look at this chart, as much as we would love for everyone in the world to use Inventor or Fusion or use our products for design, that's not the case, right? People have investments in SolidWorks, people have investments in PTC, and it's hard for people to change. So we do our best, as best we can, to make sure we work with all of those additional CAD tools. An example, in CFD, there are a lot of direct launchers, so you can go from ProE directly to CFD. I'm excited about some Fusion workflows with AnyCAD and bringing that into CFD next year. So I think, it doesn't matter where the data comes from. We want to help you make it better. I think that's kind of the short story. So,
definitely. Yeah, and if anyone has any questions about, what can get converted over, what you can do AnyCAD on, definitely let us know. We've done a couple of AnyCAD presentations in the past, and that's definitely something we can help you with. It's me specifically, so just definitely reach out with any of those questions. Cool, let's move to the next slide here. So just a couple of industry solutions, and I think the gist of this is, regardless of what industry you're in, there is a play for simulation to be able to make your designs better, whether or not you're in the automotive industry, you're in the consumer product industry, aerospace, electronics, which I guess would fall under consumer products. There's always something you can do to make your product a little bit better. And simulation is one of those things. Do you have anything to add there, Dave?
Yeah, and I think that's kind of been the exciting thing for me working for Autodesk the last 5.5 years is is, a desk, right? I have a big desk here, and you think, oh, there's not much engineering in that desk. But then you talk to people, and they're like, wow, if we can reduce the weight, we can reduce material cost and still have it be structural, we can save millions of dollars a year. At the architectural area, right? If we can reduce our energy consumption by 1%, that's $10,000 a year to a business owner. So the thing is, all these industries have needs to make their product better and more efficient, and that's the exciting thing, is I feel like we can help almost anyone. So and that's really what we want to do.
Certainly. And back to another question check. So we got a couple in since we last answered a couple of these questions. Let me go ahead and get into this. This is something that came up yesterday and came up again. Does Autodesk do fluid solid interactions, FSIs? How does that work? And I think Dave's probably a lot better versed than I am in explaining how that works.
Yeah, I can show you the process. It's initial release. Honestly, sometimes it works really well. We still have to work a few bugs out, but the process is super simple. I don't know, Nigel, if you want to send it back over to me.
Yep. And while you're jumping into that, I can answer a couple of questions. What type of mesh elements does Autodesk use? It's a pretty simple answer. Like Dave mentioned, they use those pyramid-like shapes. They're TETs in that case.
Yeah.
And we can talk a little bit about why TETs over something else. Dave, do you have anything to add to that?
Yeah. So I get one of the questions I'll hear a lot of is, well, hey, do you do hex elements? Do you do polyhedral meshes? Do you do these type elements? And well, no, we just use TETs. And now CFD uses TETs. We have some extruded prismatic elements, and we do some things with the walls, but it's primarily TETs. And the reason is over the years, our solvers, both Nastran and CFD, they've been optimized to work on those specific types of elements. So why Sim Mechanical used to do quads and do some other elements, Nastran just works better with TETs today. So that's kind of the big reason. The goal for us with our simulation tools is to get you, the customer, answers as soon as possible. And we really feel just, today TETs map the geometry better, but it's just the way that the codes have been developed. There's no reason we couldn't add other elements. We just haven't seen enough value in the solvers to do that yet. So, I wish, that does come up a lot. I just most of the product managers say, no, we get good results with TETs, and our meshers are optimized for that. So that's what we use. But anyways, fluid solid structure interaction, FSI. Here's the basic process. You see my screen, Nigel? Seen my lovely faucet?
Definitely.
I love this model, by the way. So as an example in this design, right? There's a mixer in here. Maybe reality, it's a thinner process. Maybe we're trying to go to some soft polyvinyl, and and what we don't want to do is to have these mixer blades, deflect a lot. Or maybe we're doing electronics, and we have our temperature distribution. We want to take in CAD, and we want to look at the stresses on the boards just to make sure components aren't going to pop off or something like that, right? So once you run the simulation CFD, you would go in CAD, and you would do the basic setup. And again, this one's not working right for me today, but you would set it up just like you would normally. You'd set constraints up, and then when you go to loads, check this out. I go to loads, and I just choose at the very bottom. There's a button called it's called from output, and when I choose that, I can peruse to change it to CFD files. I can peruse now. By the way, you have to make sure the CFD file is closed, otherwise I won't read it, right? But I can go into any of these files right here, and I can say, all right, read this file right here. And then what it'll actually do, though, if you had different designs or different scenarios, it would let you choose which one you want. So if you ran a transient analysis, you could pick a specific time step. If your study had different types of geometry or different wind loads, for an example, you could pick which one you wanted to do. And then you just hit OK, and basically it would take that load into Nastran in CAD, and you could run the effects of the fluid on the solid. So that's the basic process.
Yep. So the answer to that question is yes.
Yep.
Cool. I think we can answer this question while I'll jump to myself to answer some of these in-CAD questions as well. But Here's a question for a couple of people. What happened to sim mechanical? Question mark. So, Dave, do you have any insight on?
Yeah. So here's the personally, maybe it was a little too soon, but here's what basically has happened over the years. We had simulation mechanical, and then we went and we purchased Nastran and CAD. And I think the powers to be were like, wait, we have these two tools that do a lot of the same things. And then we have this whole platform Fusion. And I think what they decided is we really want to leverage Nastran and Fusion. So we don't have to support all these products. Let's pare it down a little bit. That being said, there's a lot of good things Sim Mechanical did that the other tools don't do as easily today. Hopefully we get some of that functionality back. But I think that was the rationale was behind it, was just we don't want to, Autodesk as a whole, I don't know the number, we offer like something like 248 products, and I'm sure we're trying to whittle that down to a more manageable number, and unfortunately Sim Mechanical was probably a casualty to that.
Definitely. So, but if you have any questions on, how the transition from Sim Mechanical to something like Nastran and CAD works, definitely reach out to us here at KETIV. We can help answer any questions that you do have in regards to your licensing and stuff like that. So definitely reach out. Looks like a couple more questions here. In Nastran and CAD, how do I change mesh settings? I want to make one part of my mesh finer than another. And then how customizable are materials? So actually, I can show that. Let me go ahead and just jump into.
You go, Nigel. You go.
Hey, so this file actually is part of the tutorial files in Nastran and CAD. So if you look at the knowledge network, this tutorial does live there. So if you're trying to start learning how to use InCAD, here's a great example on how to do so. And as you can see here, this bracket is welded together, right? So this angle right here is attached to this via these welds that you can see here in blue. And in this case, I wanted to make those welds a finer mesh because that's, where I think is the area of note in regards to this particular simulation. It's really easy. You can just automatically generate a mesh. You can go into your mesh settings. Let me pull this over to the other screen and kind of change the global element size of everything. Or you can jump into here, this table, this mesh table, and everything's popping up on my other screen, so I got to carry it over. So in this case, you can actually change the element size here on this this particular column. In this case, I've changed the element size of the weld to 1.5 millimeters. I'm describing this number from up here, which is the number that you're using for your simulation, or the units you're using for your simulation. In this case, it's every body has a different name, and I just changed the actual mesh size on that body. So just a couple of things to note. You can also change them all. You can do a select all and start changing some stuff there as well. So that's one thing in InCAD. The other one is materials. How customizable are materials? In InCAD, you're using the entire Autodesk and Inventor materials library. Let me just jump into some idealizations here for this. As you can see, when I'm selecting materials, let me move this over. The materials database is the materials library and the Inventor's materials library. Also, if you have custom materials, you can load those in as well. So I know a lot of people who do have it's like a slight variation of an existing material, and you can just load that in here as well. So whatever you can use in Inventor, you can use in InCAD. CFD, I'm assuming, is just about the same, right?
Yeah, we, unfortunately, we don't have the direct databases of Inventor and Autodesk yet. It would be a great thing to do, but you can customize, create your own network database if you wanted to, create your own personal user base, or just have material specific to a simulation. Definitely. But it's pretty simple. It's pretty simple to do in CFD.
Yep, and you can like override a bunch of stuff in here as you're going through these materials. So all of these constants and stuff, you can go ahead and override if you really need to on the fly. So these are things that are very, very useful. Let's see here. I think that's all those questions for now. Let's continue moving along on this PowerPoint. So. Cool. I don't own all of the simulation tools. Do they have trials? Dave, you wanna take this one?
Yes, they all have, almost all of them have trials now. CFD has a trial. If you want a Nastran InCAD trial, you actually just have to download the collections as a trial. I believe they're working. I don't know if we have a MoFlow trial available today, but there's talks of that as well.
Yep. And if you need help getting any of those, just call us here at KETIV.
Yep.
We'll make sure that
that's a great resource you have right there, Nigel. SimHub.
Yeah. Yep. So yeah, this, we were talking a little bit about it earlier, is like, it's so daunting. Where do I start? Where do I get help from people? Stuff like that. Where these forums exist? And SimHub is the answer to almost all of those questions. Simhub.autodesk.com. I use it as a resource personally a ton. I know that Dave does, and actually you create content for that stuff, don't you, Dave?
I should. I need to start creating some more, but yeah, sorry, I know all the guys that do. So yeah. And just another thing that kind of indirectly related to SimHub is all of our products have online help. All of our products have an idea station. Some of these things you guys have talked about, if there's really a strong case for different element types or so forth, submit all that stuff to the idea station. Our product managers, I promise you this is the truth. They really, if I submit something, they're probably like, Dave, you don't know what you're talking about. But when the users start submitting stuff and people start voting and kind of getting a crowd swell around it, then that's how things get implemented to the project. So if you go to SimHub, I encourage you, if you do a trial, if you're using the software now, things you don't like about it, try to constructively come up with an idea in the idea station. That is the best place, the best way you can impact the product.
Definitely. And what we'll do now is we'll let everybody type a couple of more questions. This is all the stuff that we've prepared for the webcast, but we definitely want to jump in product if you guys have any more questions specifically. Looks like I've got a couple others coming through here. One I think I can answer. For assembly specifically, how do I determine how multiple components interact with one another? For example, some of my stuff is sliding, some of it's welded, some of it's rotating, etc., etc. So actually, we actually had an AE here from KETIV do a full-blown webcast on that a couple of months ago. That's all about the contacts in Nastran InCAD, and you can find that on our YouTube channel. But here's the gist of it. Let me just jump into InCAD real quick. Over here is the tab in the ribbon for contacts, and you can either set automatic contacts when you actually set up the simulation from the beginning. Say, for example, most of your components are bonded together. You can do it that way. Or you can do manual contacts, right? You can choose two entities and then choose what kind of contact type you have between the two and the kind of penetration type you have between the two. So you've got separation, you've got bonded, sliding with no separation, separation but not sliding, offset bonded, and you can disable that as well. So just a couple of things. I know a lot of people do have multiple components in these sims, and they all interact differently with one another. For example, for this particular entity, this angle is bonded to this weld, which is bonded to this angle. But if I open this by itself, let me just do that from this other end. Let's bring this back. This back face actually isn't bonded to anything. This back face right here is just touching that angle. And so in that case, I just deleted the automatic contact between the two, even though, essentially they are butt up next to each other, literally touching. There is nothing connecting the two together from like a physical standpoint, besides them actually touching, right? No welds, no fasteners, things like that. So just a couple things to note when you're doing the simulations. Some small things like this can very much change the output. So a couple things to keep in mind. Let's see here. Can I directly compare two flow simulations side by side? I think Dave, you've got that. Do you have CFD sim open?
Yes, you can, and I encourage everyone to do that. Let's see.
Yeah, and why would you do that, Dave? Why would you compare 2 and 2 together?
Why wouldn't you, right? The idea is about making better designs and understanding which one's going to work better. This is a faucet here, model we like to use, and and these are some mixer links that are two different, they're two different diameters. Let's see if I can get, well, let me remove my frame here. Now they're two different diameters, but I can compare pressures, I can compare flow gradients, I can compare how much recirculation they're getting. And that's the idea, is you want to make better decisions and innovate. So if I have 10 crazy ideas, I can, I think simulation in general, especially CFD, when you test, you can see why something fails, right? FEA, I bend a bracket and it fails. I see the first place it's going to break. But with testing, you don't necessarily the second or third, or you don't understand why something is overheating. You have an idea, but to be able to visualize it and then compare a solution to make sure you understood that correctly, to me is priceless, right? So you can compare multiple designs, multiple scenarios. You can do the same thing in Fusion, right? This is where I could pick two different designs right here. Let me go to my compare button, right? Where in Fusion I can do the same thing. These are, you can't really tell this model. These are two different size. Change this one here. I just think this is the most valuable part of simulation, is comparing different designs. And this one should be my first one. Oops, too many models on the screen here. But as I zoom in, you can compare the different designs. Let's see, which one is this one?
Yep, and we have, how many instances of like sim do we have open? Like they're not, our computers aren't acting like, super slowly with all of this stuff open. It's, you don't need a supercomputer anymore to do sims.
No, this is my little laptop.
Yep, and I'm on my laptop too. So, and yeah, they're, with the power of computers these days and the ability to run all these simulations on, our little workstations.
Yeah, plus throw the cloud into it, where the cloud will take care of all that for you. I mean, it's even better, right? So now I have two different designs. You can kind of see there's actually more stress. This is you can see the diameter's different here. So Fusion lets you compare those things, and it could be different load cases. How much does it deflect when I push up versus push down? It could be different geometries. Again, to me, it's the most valuable part is, am I making it better? Am I addressing the problem? Are my innovative ideas working? So super simple ways to compare in both CFD and this is another one in CFD as well. These are a bunch of different designs, different heatsink designs in here. You can see as I zoom in one, it zooms them all in. One has a heatsink, one doesn't. I can compare them all. CFD can compare all the points and everything else. Let's update this real quick here. So there's my component temperature. I can compare them all side by side. It's just tremendous to be able to do that in a simple interface.
Definitely, and I hope, like just some of the stuff that we've covered today kind of helps either those people who aren't using simulation get started doing so, kind of taking away that stigma that it is super hard, because it isn't. If I can do it, anybody can do it. So that's one.
Hey, that's the line I use, Nigel. That's the line I use.
Yeah. And all of the Autodesk tools super powerful. So if you do have any questions about any of them, about your licensing, what you may or may not have already, people with collections have Nash and NCAD. And so if you want to start using some of those tools, definitely reach out to us so we can figure out what you have and maybe not using yet, if these are some things you want to start leveraging in your workflows. Let's see here. I think that's just about everything. There's some, I think, longer conversations that need to be had based on some of the questions that I'm seeing here. I'll definitely, Dave, I'll probably need to leverage some of your time. Maybe sometime tomorrow or next week, we'll see what availability looks like to kind of go over some of these bigger questions that we've got. So if I haven't answered yours directly, look forward to me getting an answer to you. In regards to the data sets, from just a quick announcement too for people here on AVA. For those of you who are looking for that iLogic data set from Thomas Fitzgerald from AVA, I just got that from him today after he edited a little bit. So look forward to that if you mentioned that you wanted to see that data set yourself. So just a couple of quick announcements for that. Let's see. And then just a real quick question I think you can answer, Dave, while we've got you here on the line. when do I go from FEA to CFD and why? Like where does that I guess that line get drawn?
So I think thermal, if you're doing anything but conduction, you should absolutely consider CFD. And then everything else, it just depends what you're doing. If you're designing tables, you probably don't need CFD, but if you have any sort of air, fluid, liquid movement, it's something you might want to consider. So FEA, stress, CFD, fluid, and I'll say heat transfer is probably a little more robust. That's kind of, there's no easy answer, but that's just the basic demarcation, I would think.
Definitely. And if people want to know specifically about if their use case is better optimized in one tool or the other, reach out to us. We can get into contact with people like Dave, people like Alan, and all of the other, Autodesk subject matter experts on those teams. We can, get their insight on what they think is probably going to be the best solution for you. So I think that's just about everything for today. I want to let everybody know, thank you for being here. Have a great holiday weekend. I guess some people are actually taking the whole week off next week. You guys are all lucky. But definitely let us know how this went. This AVA is a little bit different, right? We didn't necessarily come planned with a demo or a workflow. We wanted to be able to answer a lot of these specific customer questions. So definitely let us know if this is something you want to see moving forward. Maybe not even with SIM, maybe with Vault, for example, or things like electrical, or Inventor even, just general modeling in Inventor. Let us know. And we have the resources. Even if you want to see simulation again, I'm sure Dave would be more than happy to jump back on another webcast or maybe even a live event. So definitely let us know your thoughts about today's format moving forward. I'd be totally willing to do one of these every couple of weeks, maybe once a quarter, do a different topic. So
hey, and I'm glad if there's specific content that you as our customers want to see. I am so glad to put that together. So reach out to Nigel and let us know what you liked and what you didn't like, and we just want this time to be valuable for you.
Definitely. Yeah, and if you don't already know how to reach us, you can email questions@ketiv.com. So that's questions, that's a plural, at ketiv.com. And I can get you into contact with anyone who you need to, or just feel free to respond to any of the like, say for example, the reminder emails on Wednesdays. Feel free to respond to that. That's coming straight from me. Or the email on Thursday that's coming from Eric Paul, and he can forward that to whoever it needs to go. So any communication you see from KETIV, definitely feel free to reply to that, even if it's completely unrelated, and someone will find the right resource for that. Just say it's related to AVA, you need to talk to Nigel about something. We'll do that. But definitely thank you guys. The survey is after the webcast. You'll see it when you close it. And I think that's it. With that, I'd like to thank everyone for being here over the last just about 2 years now for AVA. I've been here for, it's been doing AVAs for over 2 years now. And I realized just now that this is the last one of 2017. So definitely any feedback, whether that's good or bad, please give it to us. And we'll definitely use some of it moving forward. So I guess with that, we'll see you all in 2018 and talk to you all soon. Thanks again, Dave, for being here today.
Yeah, thank you. Thanks, everyone.
All right, we'll talk to you soon. Bye-bye.